In this video, we're going to talk about distillation, which is a way of physically separating a mixture based on the differences in boiling points of the components. So the apparatus consists of a round bottom flask, which is then heated. This is where the mixture is initially present, and as it's heated, some of the material will vaporize. The lower the boiling point, the more it will vaporize at a given temperature. So the mixture is heated. As the vapor is sitting in this area, it comes in contact with this condenser tube. The condenser tube is a double line, 2 layers of glass, and in between the 2 layers you would have cold water flowing through. So if you have a heated up molecule that then comes in contact with the cold glass, it's going to condense, and then it will flow downhill into this nice receiving flask right here, where you can then collect that component of the mixture. So this works really well if you're separating, say you had salt water, and you wanted to get the water, which is how we make distilled water using a distillation setup. So since the salt is non-volatile, it'll remain behind in the round bottom flask. The water is heated, reaches its boiling point, and it will boil off and then recondense in this tube, and you can collect your distilled water over here. It also works for distilling mixture or separating mixtures of liquids that have different boiling points. The bigger the difference in boiling point, the better it works. If you have mixture where the components are somewhat similar in boiling point, it gets a little bit messy, but it still helps to separate. And if you repeat this process several times, you'll get a more and more pure isolated sample that you're looking for. So, say you were heating a mixture that contained a liquid that boiled at 78 degrees Celsius, and you had that in water. You would heat up the sample, and it would reach the boiling point of the first liquid. And most of it would be boiling off, and then afterwards you would see the temperature go up. But it's not a clear, like, jump, stay at that temperature, and jump up. The reason for that is because when you're heating a material, or at any point in time, there's really a distribution of kinetic energies that exist within the molecules of the sample. So if you have, at any given temperature, you have a bell curve distribution of the kinetic energies. The ones at the higher end are much more likely to evaporate, and the ones at the lower end are much less likely. And the average kinetic energy of the molecules in a sample is defined as the temperature. So if you're heating up this mixture, some of the water molecules at the high end of their kinetic energy distribution will enter the vapor phase before they reach the boiling point. Obviously, there's water vapor in the air at room temperature, so if you're heating it up to almost 80 degrees, there's going to be much more water vapor present. So some of that water vapor will be part of the mixture in here that then condenses and gets collected. However, it will be much more of that first liquid in here, a much higher percentage of the first liquid in here than there is water. And if you repeat this distillation process multiple times, you get a more and more pure sample.